Hello, I am Sanjay Kumar, Assistant Professor in Department of Mechanical Engineering. I am going to discuss the composite material, which is the most recent advancement, and also it is the requirement of current era. The use of the composite material is basically increased by their lightweight applications and also for the higher strength in manifold over the years. So there is a materials that can earlier used in automobile or aerospace applications that are heavy in weight, and also their property might be less as per the requirement, but the inclusion of that composite material, that required property of the particular applications like aerospace, the shipbuilding, the automobile engineering is increased for their lightweight application. That means they move faster as compared to the their previous material used. So the specific property of that particular material can be changed and can be achieved with the selection of particular reinforcement and the matrix material to make a composite. So nowadays that composite application in every area that can become a essential. So we are going to discuss in the detail how it is make and how we can use in the our daily area, so that the requirement or the definition that can be made with the that composite material is starting from the definition. There is no such specific definition, but in broad terms there will be a materials that in the solid in nature composed of more than one component, whereas that component in a separate phase also. So in the short terms we are concluding it that composite material made of at least two constituent but not soluble in each other. For example, if we talking about the wood, it is made up with the cellulose molecules in the matrix materials of lignin. So if the next the bone and teeth, that also the made up with the inorganic crystals like hydroxyapatite or osteons plus a matrix in the tough collagen form. This is the simple example. So we have to learn their constituents to make a composite to lighter as well as the higher strength applications. So the concept arises where the composite material can be made for a microscopic level and not soluble in each other. That is the structural material that can consist of two or more. That means the reinforcement, that is the in the form of fiber, in the form of flex or the particle, is mixed with the that particular matrix material, and we can get a different types of or different properties of the composite materials. So one constituent is called as the reinforcing phase, and it is embedded into the matrix material, and we can get the composite material as it is. So the reinforcing phase materials may be in the form of fiber, particles or the flex. It can be derived from the natural one, also it is derived from the different application of artificially derivation also. That means if we are talking about the natural fiber, there are different types of applications, like we can get the fibers from the plants, fiber from the vegetables, fiber from the animals also. That is the different category of that particular reinforcing materials. We will discuss in the detail in upcoming lectures. So for example, the concrete reinforced with the steel, as we know that our flooring which is made of the RCC, that means reinforced concrete, that is reinforcing with the steel. That means the matrix material is are concrete and the mixture of the slabs, and also the reinforcing is steel. The epoxy reinforced with the graphite fibers, this is the another example. Apart from that, the example which is related to the automobile, aerospace or the shipbuilding, there are a lot of components or part that is made up with the composite materials, which is earlier made with the alloy or the material itself. So if we are talking about that component in a composite materials, so there is a mainly two component. First one is the matrix, plus we can make a reinforcement and we can get the composite material. Mainly there is two phases. First one is the matrix. The form of matrix, which is the phase, that secondary phase is embedded in it. The secondary phase, that means there will be a reinforcement that can embedded into the matrix one. So there will be some function that is possessed by the primary phase, that is the matrix. That means it binds the fiber together. That means there will be a binder that bind the fiber which is in the nature of long or the short fiber. Also it is the terms of the particulate or the flex. But in case of that binding, the matrix can also possesses a function. It bind all the fibers and isolate the fiber, so that each and every fiber is act as a resistance or the strengthen the entire composite material. That means that fiber is the isolate and it can work as a separate entity, and it bear the separate load or stresses that can be upcoming on that particular composite. Also stops or slow down the propagation of crack. That means if there will be a matrix, then that propagation of crack will be slow down, or that can be stopped by mixing that matrix material. Also surface finish we can get a good, because there will be a separate phase of matrix where we can embedded that reinforcing material. So there will be no post processing required, there will be no other machining is required after the making of composite if we use the matrix material and that reinforcing material is embedded into that particular reinforcing material itself. So that is the simple example. Reinforcing material is the basically strengthening component, and it can act as a strengthening agent that work with the different matrix materials. So matrix work as the base material, and reinforcing is a work as a strengthening element, and that can work with the different applications. So the next question arises, why composite are important? Basically we are using the metals and alloy earlier, but why composite is required? So we have already discussed the composite material is lighter in weight as compared to the different alloy and metals, and also the superior in their property. We can make a specific property with the selection of a specific matrix and reinforcement also. So by getting that reinforcing agent, the strength to weight ratio is very high, and also stiffness to weight ratio, जिसको हम specific strength और specific weight भी हम donate करते हैं, that is the simple one. So this is the several times greater than the steel or aluminum that is the earlier used in the metal or alloying term. Apart from that, the fatigue property are greatly greater than the conventional materials in the same proportion for the applications. Also the toughness is also greater. The composite material are corrosion resistance. We can make a composite material by making their matrix and reinforcing in such a way their resistance to corrosion is very high, instead of conventional material. Like we have to use steel as a stainless steel for making it corrosion resistant, but alloying element can not stop all the corrosive environment during their application, but the composite material can serve this purpose to make it a corrosion resistance. Also, the possible to achieve combination of property. That means if we talking about the simple composite materials, then we can combine the property of the metals and alloy and also the non-metals also, like metallic, ceramic or polymer can be combined by using their matrix materials or their reinforcement to get the entirely different property with the combination of these two. The next one, the property comparison. If you are talking about the property comparison with the metals or alloy with the composite, then we have a lot of advantages with that composite material. If we are talking about the weight of the composite, then that composite material can be lighter, 1/5 type of lighter than the steel, and also 1/2 is from the aluminum. So the weight ratio for the same strength is very much low. For the thermal expansion, as any materials with the contact with the temperature is expanded, so during the operations we have to use such material where thermal expansion is minimum. So composite possesses minimum thermal expansion instead of steel or aluminum. So it is good for use in application where high temperature is running, like engine, aircraft or the automobile engine nowadays. The specific strength is also high in terms of that particular composite, like that steel and aluminum, and specific strength is very high, like 3 to 5 times during using of that composite in terms of the application. So if we are talking about their specific features, then we have already discussed in previous slides that high specific strength, basically that is the stiffness to density ratio, is achieved by making a composite, and there will be a 1/5 of the weight of particular steel. By making this composite, we have the lighter in weight and also half of the aluminum. As we know, aluminum is also lighter than the steel, but in the same stiffness there will be a much lighter, or the one of the half weight is achieved by that particular composite material. Also the specific strength, that means the strength to density ratio is also very high in terms of composite material. That means 3 to 5 times high. So using these composite materials, that particular aeroplanes or automobile can move faster and give the better efficiency, like fuel efficiency or the power output as well. So the third one, that is the net shape or near net shape, is basically nothing but it is to use the matrix in the form of the polymer or the metals or the composite to make with the materials. Their machining after post processing is very much lower or no requirement of any machinings, or reduce the process as well as the cost of making the composite itself. So the next special features that can promote the composite material is the capability for the part integration. That means earlier we are using different parts for same application to get their strength for the particular application, but we can have a single component that can process the multiple parts into a single domain, because they have the higher strength as compared to the multiple alloy or the metals itself. Also in service monitoring or online processing monitoring materials can be made by using the composite materials, and that materials is called as the smart materials. And we can have the different application area, like if we are going to monitor the nuclear power plant or their application, they can be used in the composite material for the nuclear reactor also. For the application purpose, we have the different application like civil, aerospace, the application in automobile, shipbuilding, and also the renewable field itself. If you are talking about the application area in the civil application, then there will be a barrier, the structure arcs, or even bridges, tunnels. That can be the major source where we have to use, or we are using that composite material nowadays, that give the higher strength as compared to the different available materials in steel. So in the aerospace or the aeroplane domain, there will be different panels, different outer flags, the casing, the upper fuse cells or skin, that tail, clone, radar. That maximum component will be made by using the composite. Nowadays, that lighter in applications and heavier or the higher in strength, that give the better application to use the in the automobile domain. In the automobile, we also know their door handles, the rims, also the bonnet, bumper and dashboard, mirror, frames, brake disc, rope. Maximum component are made up with that particular composite itself. Earlier, that can be used by the metallic or that alloying element for the particular applications. For the renewable, as you know, the wind turbines are basically made up with the different types of heavier steels and that different types of the alloying and alloys and metals. But nowadays, it can be made with the composite materials like laminates with the layers, that trailing edge, the laminates layers, the filler metals. That all component or maximum component is made up with the different types of composite, that is in lighter in weight, heavy in the application, and also their lifespan is very high in terms of their usage. They can also survive in the different hazardous environment as well as the different application are for the particular domains. So this is for the all about the that composite material introduction. We are going to discuss the classification in our next lecture. Thank you everyone. Thank you.